Hello everyone. I'm creating this short video to go through a question and give you a bit of a reinforcement on how to deal with the mathematical induction. First of all, let's read the question. The question is proof by mathematical induction, and always is going to be very clear to you when you need to use a mathematical induction. And show that 3 to the power of 2n plus 7 is divisible by 8 for any n belonging to z plus. It's kind of important at this stage to sort of be able to understand that and remember, of course, that z is the set of integers, so z plus is going to be the set of the positive integers. Now, the other thing that we haven't really talked at all about that the question is asking us to do is just to show that it's whatever expression we've been given is this divisible by 8. That essentially means that the given expression needs to become a product of the form 8m, comma, with m belonging to positive integers. And we will define at some point the m whilst we need it with the solution of the proof. You have seen before that every mathematical induction consists of 4 different steps, and we always go through those 4 different steps. Step number 1 to show that it's true for n equals 1 or 2 or 4 if it's specified by the question. Then the second step, which is the inductive hypothesis, we assume, so this is an assumption, right? So assume true for n equals to k, and then we move on to the inductive step where we make use of the inductive hypothesis to prove that it's also true for n equals k plus 1. Finally, we always need to show need to write a conclude statement about the work we've done, and that most of the time would be would worth 2 marks in an exam. Like I mentioned before, the step 1 is for the lowest possible value of n. Here we have n belongs to z plus, so positive integers. Therefore, for n is equal to 1, which is the smallest possible value, we have that 3 to the power of 2n, it's going to become 3 to the power of 2 times 1 plus 7, which is going to give us a 3 to the power of 2 plus 7. 3 to the power of 2 is going to give you 9 plus 7, which is equal to 16, which is a divisible by 8. For step 2, I'm moving into the inductive hypothesis. So assume the statement is true for n is equal to k, and at this stage there's nothing for you to prove. It's just about rewriting the given formula and replacing the n is equal to k. So 3 to the power of 2k plus 7 is divisible by 8. Now this is the tricky part, because you're going to have to write it as a product of 8 times m, comma, m belonging to positive integers as well. So we want it to be essentially on the 8 times table, so it has to be 8 times a positive whole number. Now I've put already on a green box the step 2, the inductive hypothesis step, and I will label it relationship number 1. And that is a key to remember, that this part, the step 2, always need to be utilized during the step 3, because that's going to simplify our life way much more when it comes to proving the inductive step. Now for the step 3, which is the inductive step, we need to prove that the statement is also true for n to be equal to k plus 1. And that's something that everybody should be able to do. So we take the original statement, which was 3 to the power of 2n, and we're going to change it 3 to the power of the 2k, the 2n, n will be replaced by the k plus 1. So 3 to the power of 2 times k plus 1 plus 7 to be also divisible by 8. Now, before on statement 1, I've used 8m to show that it's a multiple of 8. Here, I cannot use the same letter m because it's wrong to assume that this expression is also going to be 8m's. Here, I'm going to use a new variable. I could comfortably use 8n, but because I've used n again, I'm going to use a new one. So let's say 8t, comma t belongs to z plus to the positive integers. In the actual solution on the document I've shared, I've used n. N could also work, but let me just show you something different. And that's going to be my relationship 2. And now I'm going to have to prove that 2 is true. This is the inductive step where I need to do my proof. But please don't forget that you absolutely need to use step 1 in order to show that proof. So what I'm going to do, I'm going to start with the left hand side, which is that side, left hand side, and I will try to go from the left hand side to the right hand side, or the other way around. The left hand side is the one that has the more information, so I'm going to start with R, and I'm going to have 3 to the power of 2 times k plus 1 is equal to 3 to the power of 2k plus 2. And now this is the point where I'm looking up at the relationship number 1 to see how can I break down the 3 to the power of 2k plus 2 and of course plus 7 that I forgot before, to make use that the 3 to the power of 2k plus 7 is divisible by 8 is divisible by 8. So I'm going to write the 3 to the power of 2k plus 2 as 3 to the power of 2k, which is something that I have in the relationship 1, multiplied by 3 to the power of 2, and then plus another 7. And then if I carry on from here, I'm going to end up with 9 times the 3 to the power of 2k plus 7. Now this is a point where I'm going to need a bit of algebra trickery, because I've already have the 3 to the power of 2k in front of me, and here I just copy and pasted the relationship number 1 that includes the 3 to the power of k. So what am I going to do? I'm going to make the 3 to the power of 2k as the subject of this relationship in number 1. So 3 to the power of 2k is going to become 8m minus 7. And then I will substitute this one down to the relationship that I have, that I'm working so far. So that would become now 9 times of 8m minus 7 plus another 7, which is going to give me 9 times 8m minus 9 times 7 plus another 7. That would end up becoming 8 times 9m, and then minus 9 times 7 plus 1 times 7 is going to become minus 8 times 7. As you've noticed, I'm not really doing any calculations because I want to end up with 8 times something. So if I factor now 8 from both of those relationships, I'm going to end up with 9m minus 7. And then if I set up that t to be equal to 9m minus 7, then the relationship that I'm working with would become a times t, comma, with t belonging to positive integers. Now, which is the QED, right? What I had to prove. Now you might say, well, how do I know that this relationship of 9m minus 7 is going to be a positive integer? Well, we said that m is a positive integer, right? So that means that 9 times m is also going to be a positive integer. We don't know which one, and that's the whole point of doing a proof, but we know that it will be 1. And then, of course, the 9 times m minus 7 also belongs to the positive integers, and this is the how the proof works. Finally, we have to finalize all of that with the step 4, and the step 4 is the concluding statement. So let's just write this down. So step 4, concluding statement. So it's a little bit of sort of kind of like, kind of expected what you have to say at this point. You have to refer to the fact the statement is true. Is true for n equals 1. And what we did after that, we did that based on the assumption, so assuming true for n is equal to k, we prove also true for n equals k plus 1. Therefore, by the process of the mathematical induction, the initial statement, so 3 to the power of 2n plus 7 is divisible by 8. For every n positive integer. And this is how you finish the mathematical induction process.